So we were at the second step of the C3 cycle, that was a reduction. So in this, what is mean by reduction, which means here the substance will be get reduced. How? Here which substance will be get reduced? Here will be the removal of oxygen and addition of hydrogen ions. What is mean by reduction, which means the removal of O2 and addition of the hydrogen ions. In this step we'll be adding hydrogen ions and we'll be removing oxygen ions from the substances. So here 6NADH will be converted into the 6NAD, which means here reduction will be occur, right? Here you can see hydrogen ions, we can say they will get reduced. So here we were having the biphosphoglyceraldehyde, last product we were having this. Now in this step this will be biphosphoglycerate will be converted into the biphosphogyceraldehyde group. As I before discussed that it will be having aldehyde group. Now here in this step biphosphoglycerate will be converted into the phosphoglycerate aldehyde. It will be converted into this. What was the formula of what was the aldehyde group? That was, this was the aldehyde group, right? Not this one. This was the aldehyde group, which means there will be the removal or addition of the hydrogen ions and oxygen. So it will be converted into the phosphoglyceraldehyde. After that here we are having these were the molecules, that were the 6 molecules. Now here in this, from 6 molecules the one molecule will get exit. One molecule will exit. Why? For the synthesis of the glucose, as we discussed in before videos in the light reaction, that what is the purpose of the photosynthesis, which means the what were the products? That was of glucose and carbon dioxide was the products, right? And oxygen. So here one molecule of phosphoglyceraldehyde will exit for the synthesis of glucose. Now 5 molecules are remaining. Now what will happen? Now we are having third step, that is regeneration. Now what is mean by regeneration, which means here 3 ATP will be used, they will convert into a 3 ADP. Now we are having 5 molecules of phosphoglyceraldehyde, right? You can see here. Let's see on next page. We are having 5 molecules, right? We are having 5 molecules. 1, 2, 3, here 4 and 5, right? These are the 5 molecules of phosphoglyceraldehyde. Now from this, what is mean by regeneration, which means regeneration of that molecules that we reduced in the second step, right? So here we have to make the 3 molecules of RUBP. How as we discussed in before, what was the how many carbons were there in the RUBP? There was the 6 carbon was the RUBP there was. Now from these 5 molecules we have to make 3 RUBP with the 6 carbons. So how we will make 3? We will having 6 molecules, right? After that here 6, here we are having 3 molecules of RUBP, like 3, 4, 5, and 3 is 4, 5, and 3. Sorry, here we are having 5 carbon. RUBP was 5 carbon, not 6. 6 was the glucose, right? 5 carbon. So here this one, and here this one second molecule, and after that this one and this one. Now you can count here 3, we can say we are having 3 molecules, that are the 5 molecules. When we regenerate them, we will get the 3 molecules that are 5 carbon sugar, so that we will get the 3 RUBP that are the 5 carbon, right? So this was the regeneration step. Now as we know, in first step we use 3 RUBP molecules. Now cycle will again work after putting 3 molecules of CO2, which means here we have get the 3 molecules of RUBP. Now this cycle will again move, and as in first step we have consumed these 3 RUBP, here it was consumed, and here we have get this RUBP in last step, right? Now this cycle will again move, and we will, when we will add CO2, we will again move that cycle. So by adding this cycle we will get more RUBP and energy. So that was the, we can see is 3 cycles last step. Now if you see the we can say cycle, Calvin cycle, how it works. Calvin cycle, here we have used 3 CO2, right? 3 molecules of CO2, and here we have used 3 molecules of the RUBP, right? Three molecules of RUBP. So when in second step, when in first step, when we can say break these molecules, we get, in first step that was a carbon fixation, right? So here we get the 6 molecules. These were the 3 molecules, and here after breaking these, after the carbon fixation, we get the 6 molecules of that was the phosphoglycerate. Here we have used number 1 step. Here we get 6 molecules, that was a phosphoglycerate, 6 molecules. After that, here we have used 6 ATP, right? 6 ATP are used, and phosphate is scanned and it makes a 6 ADP. Here we have used 1 phosphate with each molecule, that's why it takes 6 ATP. After that, in second step, in reduction, now it is make the 1,3 biphosphoglycerate. This is a 1,3 biphosphoglycerate. After that, now second step. In second step, what we have done the, we can say, and 6 NADPH is converted into the 6 NADP in the reduction step. So here we are having, in the reduction step, NADPH 6, and it will convert into 6 NADP. So that was the reduction step. Now from these were 6 molecules, right? Now from these 6, one molecule exit for the glucose synthesis, right? Now from here cycle continues. Now 5 molecules of we are having phosphoglyceraldehyde. After that, here 5 molecules we are having. Now here 3 ATP are used to make, we can say, phosphate, to add 1 phosphate to in it. 3 ATPs are used, right? So here we get 3 molecules in the step of regeneration. Here we are having third step. 3 molecules of RUBP. Again we have get 3 RUBP. Then we add this one. So that was all about this cycle that we have discussed in 3 steps, that is known as the Calvin cycle. Now you can see here again, here we have used 3 carbon molecules and 3, we can say, RUBP. Now in last step we can say we have give product to same cycle. We have when in first step we have consumed this one, in next step this is our product, we have given same. Now this RUBP will be used again with the 3CO2 and this cycle will continue same. So that was all about the light independent reaction.